Welcome everyone back to SAT Math Question of the Day with Professor Emeritus. Wait, is it? It's Math SAT Question of the Day, isn't it? Yes, it's
Yeah.
Math SAT Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and that's Brother Joel. We're here to hopefully show you how to approach SAT math questions and also how to study for the Math SAT. After 2016, that reminds me, today is also Throwback Thursday, where we look at a test that was published before 2016, when the tests were more like reasoning tests, but that's for later. So, we suggest to help you study for the Math SAT, you subscribe to Khan, which is free, after you sign up with the College Board, and they list the 40 topics that are on the Math SAT. They also list all the English topics as well, and they give you 20 questions per topic. We are at the 11th question, because this little thing means we are at the 11th question, and we did one already in our series. So we are doing the 12th question in this series, and this is a series called Radical and Rational Equations. Okay, without any further ado, why don't you please read it, try it, come back, and we will do it. And we will show you at least one way to approach it, maybe two ways to approach it, or multiple ways to approach it. Okay, what's the sum of all the solutions of the above equation? So it's a radical equation. And what you need, traditionally, what you do with this is you get the radical by itself, you isolate the radical, you square both sides, and then you go from there. And in this case, when they say sum of all solutions, doesn't that remind you of that theorem that the sum of the solutions of a quadratic, oh, by the way, you're going to get a quadratic, sum of the solutions of a quadratic is the negative of the linear term of the quadratic. So that seems to be the way to approach it. This is not a bad way to approach questions. When you look at it, you analyze your plan. What are you going to do? That's a good way to approach problems. Then you do it. So this is this negative. Oh, by the way, when you square both sides, you have to check extraneous solutions, but it's not likely that they're going to be doing an extraneous solution here. Oh, look at this. This is negative y plus 3. Tons of negative signs. Wow. And then you square both sides. So this would be, why do we get this negative sign out of there? I just feel more comfortable. So, although it's probably not necessary. Y minus 3. I just transferred the negative sign, multiply both sides by negative 1. You didn't really need to, but it just looks nicer. And then 7y minus 31. This is a race to the finish. Seth's winning. You square both sides, y minus 3 squared. This is y squared minus 6y plus 9. Now you want to make this equal to 0, so you subtract 7y. Oh, that's the only term we care about, actually. Yeah, so who cares about the 31? So it's y squared minus 13y. So it looks to me like the sum of the roots of this equation is positive 13. All right, Seth, good job. Yeah. Right. And so Seth showed the theory as to why this is that technically a theorem, or is it a relationship? When you say the sum of the roots of a quadratic equation is the negative of the linear term, is that a theorem? What is that? What do you call that? An observation?
It's a theorem.
A theorem, and Seth proved it. Good job, Seth. And who cares about the linear term, right? Remember, who cares about the linear term? Because you're wasting your time if you do the 31 and move it over. Is there another way? By the time you try to come up with another way to do this, you might as well just do it. I don't know if there's a way to see it ahead of time. Probably not. Certainly not with the experience that most people taking the Math SAT would have. Seth?
I'm thinking about it.
Oh, wow. Well, if Seth's taking this long to think, then you know that the best way to do it is straight road, just classic, just way to do it. And I'm sure when we look at the solution, they're going to do it the exact same way. Don't forget, when you square both sides of an equation, there's something called extraneous solutions, but that's not coming in here. You are going to have to know that thing. They certainly require it because the Khan Academy has a relationship with the SAT. Then you have to know that the sum of the roots of a quadratic equation is equal to the negative of the middle term when the middle term is x squared plus x plus the constant.
Well, I could play like this.
Yep.
You're right. I don't know what's going to happen.
It's a nice capital L, by the way.
Yes.
Hmm. Very, very nice L. I don't even think.
Let's just play with it.
There's the capital L. I'm checking out. Look at that. Very nice.
Let's just play with this.
Okay. That's, by the way, a really good approach. That's why Seth is pretty good in math, because he doesn't hesitate just to play with things. And that's a good thing to do. If you're lucky enough to have the time just to play with the numbers, you get extra insight. And that's a very important part of really learning anything, is to play with it. You never know what maybe you'll see an insight that no one ever told you about before, or exists but no one told you, and then you look it up and say, wow, look at that, I found an insight myself. Nothing like finding out insights yourself. And then if you're lucky, you'd be the only one in the world to see it. And more likely in these problems that other people have seen it. But wow, what is that doing? That looks algebraically, let's give him some space.
So we got the sum. So what could you say here? That's me. So we have the sum of the roots, which is what you want. The sum, wow, equals 6 plus the square root of these two.
Oh, wow. So that's like doing serious theory here. He's trying to do a backdoor way of saying that each root is S1 and S2, plugging it into the equation and doing algebraic stuff to see something.
I don't see any dead end. I think this is a dead end.
Yeah. Yeah. Wow. Yeah. Yeah. But it's still a good thing to do, is to look at problems from different perspectives.
Yeah. Another thing to do is, I don't know. So this is a radical equation. I don't know. I don't know what to do. I don't know.
So we might as well just look at the answer and then move on to Throwback Thursday.
Yeah. Okay. So
this is an interesting question, that there really was only one practical way to do it. A lot of the SAT questions.
We don't know.
But
we can only think of one practical way to do it.
No, but if it takes this long to figure out another way to do it, that's what I mean. There's no other practical way.
No. Some mathematicians might have another idea, or they might think longer than you and actually find one.
Yes, but
just because you can't figure it out doesn't mean that it's impossible.
Well, okay,
that's what mathematics is about. That's mathematicians gain. They're very happy, and they gain recognition when they figure out something that nobody has figured out before.
I totally agree. Of course, obviously,
you cannot say that there is no better way.
No, but
I said we do not know of a better way. That's different from saying there is no better way.
Of course, that's not. But the question is being practical. I'm changing the engineer. I like to think practically. The people taking this test at the level of 10th to 11th grade math, that since it's really doesn't seem that easy to come up with another way, the probability of someone at the level they're taking the SAT to come up with another brilliant way of doing this is extraordinarily low. Yes, a brilliant mathematician could possibly come up with this, but we're talking about our audience who's taking the test.
Well, I'm talking about the whole world.
No, I'm not. But the whole world isn't taking this test. Only only 10th and 11th graders in high school in the United States.
Well,
There's another
after
person.
before long, they'll become 13th, 14th, 15th, and before they know it, they'll be 25th, 27th, 40, 80th graders.
Yes,
They'll
exactly.
be in
And
the
then they'll have their
80th grade,
right. Yeah. No, but by that time you're too old for that
100th
creative
grade.
stuff. Yes. They'll be at that peak time,
They'll
which
be
is what?
completely
Between like 18.
forgotten and forgetting.
Yeah, what is the peak time of creativity? Between like
Ultimately,
what's the peak time of creativity from like 18 to 24 or something, to 18 to 28 or something? Yeah, when they're 18 to
well, that's
28.
debatable. Yeah.
I know. But when they're a little older, then they'll have their chance to come up with some brilliant way to do this. Anyway, this is silly. We're having a silly
Okay, let's
conversation.
let's let's
It's
see
a
let's see
completely silly conversation.
let's see what answer they give.
Typical of us as brothers. Typical of us as brothers.
Difficult, yeah, yeah.
Okay, I think this is the answer. Let's see. Fireworks? Yes, fireworks. Okay, let's see how they do it. I'm sure they do it the plain way. For radical equations, vowel radical, on a reagent, so the radical term
That's
appears on
exactly
one
what you
side.
said.
Yeah, you have to isolate the unknown. You have to isolate the radical. Well, actually, not the unknown, but the radical. You square both sides. They don't talk about extraneous solutions. Don't forget extraneous solutions is extremely important. But it doesn't come up here. You get oh, look, they wasted their time. Why are they doing that? They're doing everyone a disservice. Who cares about this number? And they didn't think backwards. Wait, oh my God. They did consider extraneous solutions. Wait. Whoa, look at this. Seth. Okay. So this is an extremely important question for Seth. Could we possibly have done it? Could we have possibly run into a situation where where there is no solution to this equation, but by looking at the quadratic, we did the sum of the solutions and we could have been wrong? In other words, did we have to actually get the solutions to this problem, check them to see if they're valid, then take the sum? Maybe we should have. What do you, Seth's thinking?
Well, maybe, yeah. The symbol square root in these problems, doesn't that mean the positive square root?
Yes, absolutely.
Yeah. So I think you have to check.
Wow, we were really wrong. Philip, conceptually.
Like for example,
wow.
Here we go. X. Here's the issue. Yeah, here we go. So what mathematicians like to do is look at this. Look at the simplest case. Suppose you have the following equation: X equals the square root of 1, right? Now, the symbol square root is the symbol square root means positive.
Right.
In other words, the z greater than or equal to 0, such that z squared, equals a. Okay, so 1 solves the equation because 1 equals 1 squared. What about -1?
No, -1 won't work.
It's not positive. -1 squared equals 1, yes. But -1 is greater than 0, no. Okay?
Right.
So, and indeed, if you were to take this equation and square it, get the equation x squared equals 1, right? Which has 2 roots. X could be 1, and that could be -1.
Yeah, I always use that example also to show why you have to check for extraneous solutions. So the sum of the roots is 0.
So
the sum of the roots is 0, but the answer But you can't say that
Yeah,
because
yeah.
there is no
So,
second root, right? Ouch.
okay, so
So it's
can
true.
you have however, in this situation, the radical was taken over a variable expression.
Mm,
It's a linear expression. If there were two different roots, the square root would be taken of two different things.
right,
And so the two positive square roots would be different,
right.
right? Two different things.
Yeah,
First of all, this level of test, they're only talking about the real numbers.
of course.
So uh, each of these, if y is a root, each of the these linear things in y has to be positive, and if they're different, then they have to be different, and therefore the values of y. So if the values of y that fit in here have to be different. Okay, so I would say you could look at it and not and prove that there are no extraneous solutions.
Wait, but I've certainly seen equations that look like the top one there. That
Which one? The
that
red one?
uh, let me get back the annotations
Mm.
because I have the screen. I have to be concerned about that. No, I've certainly seen equations like this that have extraneous solutions.
Yeah, yeah. Here's one. Here's one. Here's a one. An equation that looks like this, but
It
it's
looks like
really this form. Take this
wait,
y
that's the only time you
minus.
no
What's going on? Uh,
no.
y.
I've seen equations that look
Suppose they pose this. Uh, make it positive. They didn't put a y in here.
wait, hold on. I've definitely seen equations that look like that.
With the y inside,
Yeah, of course.
where the inside value varies with y.
Absolutely, and they don't seem to have this type of pretty. They don't have a. Yeah,
Yeah.
they look like regular quadratics. Absolutely. I don't know if we have the time, and if we personally,
Yeah.
Seth and I would then
Well,
go off
you could
screen and
find it.
find
Yeah,
one.
try to find, but I don't know. Yeah, yeah. So what we maybe would have to have is a case with
I'm gonna find one.
one root, with one root. Uh, some expression involving one root, some constant.
Extraneous solutions are a big deal, as you can
But
see
yeah,
by
yeah,
the
yeah. Here,
necessary
so
statement.
this is some formula containing R1, and there's another formula containing R1. In the case of, and let's write the same situation with R2, plus or minus something involving R2 equals the same constant. Okay. Now we have extraneous root. If this equation with R2 is satisfied when the negative root is used here, and this one is satisfied when the positive root is used, you could find a situation like this. Then a solution, the solution obtained by isolating the radical and squaring it would become extraneous. So could you actually find a problem that has this form?
Yes, 277 to 281. 277. Hopefully they'll have a nice one. 277. Yes. Yes. Uh, uh, um, wait. Okay. Yeah. Yeah. We have an extraneous solution. Here we go. Okay. How about this one?
Hmm.
Oh, this is a nasty question. Oh my God, this is a double one. Oh, uh, oh, nobody. Wait, we're gonna have to. This. Oh wait. Can I clear everything you wrote, or do you need it
Yeah.
there? You need it there. Oh, this is a really hard one to deal with right now. Oh wait. Uh, okay. Here's a simpler one. Okay, this one's not bad. This one's not bad. 3x. I'll write neatly. Okay. Minus 5 square root of x equals 2. Um. Yeah. Okay. 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 Yeah. So that's cool. So this is negative 5 square root of x is equal to 2 minus 3x. Should we get rid of the negative sign? 5 radical
Yeah.
x is equal to 3x minus 2. Notice this negative,
Yeah.
having a negative sign there could really, maybe is, could be a problem. I don't know. Uh, okay, does that look right?
Well, if the left side is negative, then
So
well,
let's solve it.
okay.
So I have a
The left side is negative.
25
Then
x
the right
squared.
side might be negative with x positive if x is less than 2/3.
Okay, so we have 0 is equal to 9x minus, no, this is a x, minus 37x
9x
plus.
squared.
Right, yes, I'll get that. That's right. Okay, now that's
And write this, put the square in the line above. I don't like to see faulty
That's right. That's
equations.
right. That's right. That's right. No, you're totally correct. Totally correct. Now, this is a real painless factor, but I'm looking at the book. Okay, we're not here to do the problem. We're here to demonstrate something. So the book says the factor like this: 9x, 9x and x. Okay, 9x and x. So it's 9x minus 1 and x minus 4. So what we do is we double check the book. 9x squared, yeah, this is 36, and add an extra 1, that's minus 37 plus 4, we're fine. So x equals 4, and x equals a positive ninth. The sum of the
Yeah,
roots is,
smaller than 2/3. Yeah,
what?
yeah, smaller than 2/3.
So in this case, there is an extraneous solution.
Yeah,
It
yeah.
turns out that the 1/9 doesn't work. Yeah, the 1/9 doesn't work. So why doesn't the 1/9 work?
Well, let's plug it in. You
Yeah.
get 3. It's 3 times 1/9, right? Minus 5 times the square root of 1/9
Which is a third.
should equal 2.
Should equal
And
2, yeah.
right, this is so 3 times 1/9 is 1/3.
Right.
The square root of 1/9, the positive square root is 1/3.
Yeah.
Uh, uh, the positive square root of 1/9 is a third.
Right.
And so we have minus 5/3. So the minus 5/3 plus 1/3 is
minus 4.
minus 4/3.
Minus 4/3, yeah.
Yeah.
Doesn't equal 2.
However, if you took the negative square root of 1/9, you get 1/3 plus 5/3, which is 6/3.
Right. Yeah. Yeah.
Yeah.
Yeah. Yeah.
Yeah, there we go.
So what the important takeaway here is that you can have one of these problems, which we have right here. It has different roots, and they are not. One of them is not valid, so you can't take the sum of the roots. So guess what? We were both wrong. And what's interesting about it is when you're wrong, it's good to really think about why you're wrong, and that really strengthens your skill. So hopefully we won't make this mistake again.
Yeah.
It's
Yeah.
important when you're wrong to take the time. I'm sorry we did, but we had to. We had to figure out
Yeah.
what
Yeah.
we did
Yeah.
wrong and justify it and say
Yeah.
and learn from it. And this is a major approach to really, trying to get good at this stuff. So yeah, you can have two different roots, and one of them can be not equal, not equal. Well, I said that right. You can have
Yeah.
this type of thing.
Yeah.
Yeah.
Now, what we didn't calculate. Let me think. What would we? However, we did show that there are no other routes to the our first problem.
Yeah.
Besides the two that we found.
Well, we never
because what we did was we took the equation. We the logic that we followed was that we made the following: said if x were a root, then the equation with the radical would be satisfied.
Right.
And then if the equation with the radical is satisfied, then the equation we derive from it would be satisfied. Yeah. And we were able to derive from it equation of the form x equals something.
No, we had a quadratic, which then we
have a quadratic, and then from that quadratic we conclude that x either equals one of the roots or the other root.
No. What? That.
So we did not. So we proved that the only roots of the original equation could be the two roots of the quadratic, which is different from saying that. A root of the quadratic must be a root of the original.
Yeah.
We say, in other words, what we did was that if a number is a root of the original, then it must satisfy the quadratic.
And you're saying
that is the converse of saying that if a root is of the quadratic, then it's a root of the original.
So we were wrong.
All elephants are gray. But is different from saying every gray animal is an elephant.
Right.
So a converse statements are not equivalent.
So in other words, we were wrong.
We were wrong. Yeah, we were wrong.
Yeah, we were wrong.
The problem was to find the roots of the original equation and then report their sum.
That's exactly
right. And we did not assure ourselves that the two numbers we got from the quadratic are roots to the original.
Absolutely right. Well said, Seth. That's right. Yeah. So to have done it the proper way, you actually would have to. You actually would.
So if they gave us this the Joel's equation, and they said find the sum of the roots. And what we did was, we said, well, the sum was 4 plus a ninth. That would be wrong.
That's right. We'd be wrong. Now, if we looked at the equation and what we did, I think people realize already what we did, is we looked at this quadratic and we said, the sum of the roots, the negative sum of the roots is 37 over 9.
Yeah.
And we did not actually do this step, okay, of actually getting the roots and checking. That's what they are doing here. That's a long problem. Wow, considering it's only number 12
Yeah,
of 20.
but
I
it's
hate to
it's
say
a
this
it's
question.
a it's a problem with the property that if you it's an easier problem because if you did commit that mistake in logic, you still come out with the correct answer. So the lesson in thinking here is that sometimes using faulty logic will give you an answer that is correct.
Wait, but also let's think about this. This is a multiple
Sometimes
choice
if you make a
test.
mistake in reasoning, you'll still come out with the truth.
Wait. But let's say, okay, what would have been the answer to this question? What would the sum of the roots of this equation be? The sum of the roots of no, the sum of the roots of this thing. The sum of the roots of this would be 4.
Yeah, there's only
It
there's
would be
only
4.
there's
It would be
only
4.
one root. It is 4.
It is 4. Now don't forget this is
So
a
the sum of
multiple
the roots
choice
is
test.
4.
This is a multiple choice test. So if this question was given as a multiple choice test, they would have one answer be 4 and one answer be 37 over 9 as a distractor.
Yeah.
Right.
And one answer would be 4 plus one answer would be 4 and a ninth.
Seth, that's just what I said. 37 over 9. That's what I said.
Well, they could write 4 and a ninth.
But, oh, fine. Look, it doesn't matter whether it's 37 over 9 or 4 and a 9. But they would have given this question, if they really want to give a trick, right? They would have said this problem right here.
Yeah.
Then they would have said answer A is 4, which is the sum of the only valid root, and then the sum of then this little game, the negative B over 2A thing.
Yeah. Yeah.
Wow.
Yeah. Well, that's why some of our commentators have written that the SAT is very easy.
What do you mean it's very easy?
And we gotten criticism that the SAT is extremely easy.
Wow, this would have been
well relative to math that could be questioned about and is questioned about in other parts of the world.
Right.
The SAT is very easy.
Yeah, absolutely.
So, shall we do a Throwback Thursday?
Yes. So we spent a lot of time on this. Why? Because we made a mistake. When you do it, if you make a mistake, spend a lot of time analyzing why you got it wrong and really understand it. Wow, hopefully we're not going to get burned by this again. Anytime there's an extraneous solution, you got to check the extraneous solutions. I was so wrong when I said, don't worry about the extraneous solutions. Wrong. Okay. Throwback Thursday. Ooh. Okay, our confidence has just been damaged slightly. Maybe more than slightly. Okay, Throwback Thursday. This is coming from a test probably about around 2000, maybe 1997. This big, thick book. This is an official SAT published by them. Back then, they had these questions where you had to choose. You had a column A and a column B. Sounds like a game show. And the instructions on the top. You answer A if column A is greater, B if column B is greater, C if the two are equal, D if the relationship cannot be determined from the information given. The word given is slightly taken off there. See that? See the word given? Okay, so that's it. Okay, here we go. Please read it, think about it, pause it, and let's go. Oh boy. And I'm not going to do Zyport. I'll annotate in Zoom to be fair for Seth. And I'll use Seth likes red. I like blue.
I'm using blue. Now.
Blue? Oh no, I gotta use. I'll use. Oh God, what do I use? Orange.
Okay, Q. I'm doing it in blue.
Okay, fine.
So P is one. Presumably, is a points on the line. P is 1 point. Q is another point. And P and T are two lines.
That's
2
right.
points, 2 points, and Q is somewhere between them, right? And the thing is, compare the ratio, 2 ratios. In these ratios, the numerator is the same, but the denominators are different. One denominator is this distance to wherever Q is from P. And the other denominator is the distance to wherever Q is from T. Now, Q might be anywhere. If Q is closer to P, then the QT quantity is bigger than the QP quantity. On the other hand, if it's the other way, then QT is smaller than QP. And so there's no, you cannot conclude anything about the relative bigness of the denominators. The numerators are equal, and so you cannot give any conclusion to comparing the values of the fractions. And so the answer is D. You cannot tell.
Right. Yeah. I see. Yeah. I can put numbers. That's so smart. He can't do. He can do without numbers. I can't do that. I have to throw some numbers in. So then, yeah, you can just reverse this, right? You could do 10 over
Right.
7 is 10 over 3. Now, I was being silly here because I always get burned on these things with positive and negative signs. And then I realize these are all distances. So you don't have to worry about the two numbers on the number line being less than 0, two numbers on the number line being greater than 0, or the numbers crossing 0, right? You don't have to be concerned about that because we're doing distance, right, Seth?
Right.
Yeah, okay, good. Thankfully. Okay,
and
so
notice
saying...
they did write these so that even if you did give these assigned differences,
Yeah.
now sometimes they will write the distance from P to T,
Right.
the negative of the distance from T to P.
Yep.
Even if they did that, it would be, same thing. Because they carefully wrote, no, P to T is in the numerator, and then the denominator, P to Q.
Oh, wow.
P to Q, and then in the second one, Q to T. So they set it up so that either assigned interpretation of one of pair points to denoting a number, or the unsigned interpretation, or either interpretation, you cannot make a deduction about the relative size of the ratio.
I noticed that this question doesn't really fall into any of the 4 categories. Well, maybe number line, but it doesn't really fall into any of the 40 categories that the Khan Academy and the SAT, well, the SAT, as said, is on the post-2016 SAT. Yes, you are right, Seth. The answer in the book is D. And this book does not give any explanations for any answer. They just give you the answers. But I did find a great question for next week for Throwback Thursday, and we're not going to do it. Well, look at this thing. This is a funky looking question. Look at this. Look at this thing. You got these chains and you got this stuff. It's so different. The question looks so different from the modern test. So that will be our Throwback Thursday question next Thursday. Okay, I guess that's it, right? Now Seth's recovering from that extraneous solution problem.
That's it.
Okay, everyone, have a great day. Please email us or please comment on our videos and email us at wow, am I having a brain freeze? Is it SAT math question of the day or it's math SAT question of the day, right? Or is it? This is really embarrassing. Wow. Let us. Yeah. Okay. It is I think it's SAT math question of the day at gmail.com. Email us then and give us comments, likes or dislikes, and we hope to see you tomorrow. Okay, everyone. Have a great day.
Okay.
Yep. Have a great day.
Bye.
Bye-bye.